Okay, this is the example problem that I'm going to discuss. Read it. An elastic string of length L. Length L means this is the natural length, and modulus of elasticity, that constant, is given as 4 mg, is connected with the mass m and hanging vertically from a point A. Find the extension of the string. So that is the first part. So string is connected to a point A. Natural length L. Then when we connect this mass M, definitely it's going to extend beyond its natural length. Extend beyond its natural length. We don't know this extension. Let me label that as E, not X. E, extension is E. So the mass we have connected is M. Then weight becomes mg. Then the opposing force, resistive force, is tension. Lambda, modulus of elasticity, is given as 4 mg. Okay, now we can apply our tension equation. Tension of an elastic string is equivalent to modulus of elasticity into extension divided by its natural length. So this is from theory. Then modulus of elasticity is given as 4 mg in the problem. Extension we don't know, that is E, over natural length is L. Then what is tension? We can apply equilibrium for this, because this particle mass is in equilibrium. Then upward forces equals downward forces. Tension equals mg. Then we can cancel mg in both sides. We clearly know m is the mass, gravitational acceleration, it is a constant. They cannot be zero. So when we are cancelling both sides like this, we have to mention everything is not equal to 0. Then since they are asking extension, we can subject extension, that is L over 4. Extension is L over 4. Second part. Now the particle is kept at capital B, which is L distance below A, and projected downwards. Now the second part. Particle is kept at B, hanging from A, natural length is L, and they have mentioned this point B is L distance below A. That means B is exactly at the natural length of the string, and the particle is projected downwards with a velocity of, what is the velocity? Square root 6gl. It is projected downwards. If C is the lowest point reached by the particle, then what will happen? Due to this velocity, the string will extend, because this is an elastic string. So it will extend to a point C. It is given lowest point as C. Then show that M performs a simple harmonic motion. M performs simple harmonic motion of amplitude 5L over 4. M performs a simple harmonic motion. So that is the first thing we have to prove in these kind of problems. For that, this is the starting point of our motion. We have to consider the general location of this motion. Now this is going to perform a simple harmonic motion. We have to prove that. Therefore, I have to consider the particle at a general point somewhere here. And also I am going to mark this extension as x. This is the extension. Now these two diagrams are different. This is for the first part. Now this is the new extension. I used x. Then we have downward force, which is weight. Then upward force is tension of the string. Now what is the starting point of our calculation? F equals ma. Now x is measured downwards. Therefore, I am going to apply F equals ma downwards. These are the finer points you have to keep in mind. If you apply that upwards, you won't get that answer. So if I am going to measure x downward, I have to apply F equals ma downwards. Then downward force is mg minus upward force is tension, m into acceleration is x double dot. Displacement is x, then acceleration is second derivative of displacement x double dot. Then what is the tension? Tension is equivalent to modulus of elasticity into extension over natural length. What is the modulus of elasticity? OMG into what is the extension now for this diagram? That is x. X over natural length is L. That is unchanged. Mx double dot. Now we can cancel m in both sides. M not equals 0. You have to write that. Now characteristic equation is in this form. So we have to subject x double dot and take a minus constant and an x term. This x term in most cases can be a bracket like this, x minus a different constant. Now I will take x double dot here, then minus 4g x over L is the first term I am going to write, because I have to take this negative sign. Then I have to consider the negative term first. Then if I want to keep x, only x inside the bracket, I have to take all the other things out as the common factor. If I want only x inside the bracket, I have to take 4g over L, all these things out. So that is minus 4g over L is taken as the common factor. Then inside bracket we have x, that is our requirement. Then here what will happen to this term? There is g term, so g is taken out, but there was minus in the common factor. We didn't have a minus for that term, then I have to put minus. We didn't have 4 is in numerator. By force I have taken 4 out. To correct that, I have to divide that by 4. Then there was no L here. By force I have taken L in the denominator, and I have to keep L in numerator. So this is simple simplification, taking the common factors out. Now this is in this form. After obtaining this, I can write the statement. You have to write this one to get full marks. What is that? This is in the form of characteristic equation of simple harmonic motion. This is in the form of a characteristic equation of simple harmonic motion, where now we have to mention what is omega square in this particular motion. That is the constant in front of x, constant in front of this bracket. That is 4g over L. And center. What is the center of this simple harmonic motion? Center is the value of x. Center is the value of x when we equate this bracket to 0. How can we find x? X is the value of the bracket when we equate that to 0. Equate the bracket to 0, then x is 4 over L. Then center is L over 4. Center is L over 4. So these two things you should identify in the process of showing the motion is simple harmonic. Okay. Then third part. Now we have shown M performs simple harmonic motion. Then is the amplitude 5L over 4? We have to find that. Is that amplitude 5L over 4? Center of our motion is L over 4. Our motion started from this location P. Why? We have measured x from here. Then when x goes to L by 4, we can reach the center. Now let's mark another point somewhere here. This is, let's say, that is D. D is my center point, center of the simple harmonic motion. This kind of a motion, that center, this is my D. This D is L over 4 below B. That's what we found here. Center is L over 4 away from starting point. So this is the center. Okay. Now we have to find the amplitude. Can you remember this equation? Second equation we discussed. V square equals omega square into amplitude square minus displacement square. Now, in this motion, at which point we know the velocity? Velocity is given at D. It is square root 6dl. Now we can apply this equation to point B. So at B, velocity is this. When we square, we have 6dl. Omega square is equivalent to 4g over L into, we don't know amplitude, unknown, minus x. What is x? X is the distance to this point from center. Now we have already calculated our center, that is marked as D. D is the center. Then from D, what is the distance to B? Because we are applying this equation at B. that is L by 4. Distance is L by 4. X is that. Then square is L square over 16. Okay, now simplify. G cancel with G. 2 times 2, 2 times 3. Now cross multiply by L. Then here we have 3 L into L square. Here we have 2. Divide that by 2. 3 by 2 L square. Amplitude square minus L square over 16. Now subject A square. 3 over 2 L square plus L square over 16. Common denominator 16. 24 L square plus L square. 25 L square over 16. That is amplitude square. Therefore, what is amplitude? Take the square root of this. 5 over 4 L. Amplitude is a length, distance, so it cannot be negative. Therefore, no need to consider plus or minus when we take the square root. We can take only positive value. So amplitude is 5L over 4. 5L over 4. We have already calculated amplitude. See, we had to use characteristic equation and the second equation, which I taught in previous explanation. Then show that the time taken by mass m to move from B to C. Now the application of third equation, time equation. What was that? Time was equivalent to angle covered divided by omega. Third equation. Okay. Now I'm going to use different paper because I want to draw this diagram clearly, because there is a small construction to be done. This is point B. Center D. Extreme point C. Now there is another thing we can mark. In this calculation, we calculated the amplitude as 5L over 4. They have given C is the lowest point reached by the particle. Lowest point means the amplitude. Amplitude is the lowest point can be reached by the particle. That is 5L over 4. Then what can you say about this entire length? Think, what is that length? In this diagram, we measured from B. X was measured from B. Now we have our amplitude as 5L over 4. Amplitude is the maximum displacement by the particle to either side of the motion. Amplitude is the maximum displacement of the particle to either side. Can be upward, can be downward. If this is the center and C is the lowest point, that is the maximum point the particle can reach, then this should be the amplitude. This is the amplitude. So what is this? This is 5L over 4. That is the amplitude. Okay. Now, to find time, we have to construct an arc. We are going to construct an arc from the amplitude point, from the extreme point, or in this case, from the lowest point. we are going to construct an arc like this. So it may stop from here or somewhere here in between, or can go beyond this, beyond the ceiling. So we don't know. Therefore, we just continue that arc, and from center of this arc is D. That is the center of the motion. They are asking the time from B to C. B to C, we have to measure time. Then we have to consider our motion from B to C, here to here, here to here. So we are going to stop our motion at B. Because of that reason, we have to stop this arc by drawing a horizontal from B. We are drawing a horizontal. That means the particle is moving along this line. But from this arc, we are thinking the particle is moving in this path, because we want an angle. From this vertical movement, we can't measure an angle. Then from here to here, what is the angle? For that, if this is the center, I am going to connect the center with this point. So that is the trick we are going to use to measure the angle. Okay, in every simple harmonic motion problem, this is the way. We can't measure a distance by just considering this vertical up and down motion. We can't see the motion. So for that, we are going to construct an arc away from this vertical line. Then we can see there is an angle. That is the angle. This is the angle where the particle is covering under its simple harmonic motion. Okay, so this construction is important to find a time. Okay. Then where to mark this theta angle? That is the other thing, other important thing. Where to mark? We have to mark a theta angle here in this particular diagram. That is observed, that is taken from this show that expression. I repeat, if you didn't get anything, how the logic behind this, just you have to complete this up to your amplitude extreme point and draw an arc like this. Okay, then connect the circumference of the arc with the finishing point with a horizontal line. Then that is the finishing point, this is the starting point. We have to measure that arc, sector, angle, then construct this line which create a sector like this. That's it. Then take the expression and check what are the angles given. This is pi by 2, 90 angle is given. Here we have 90 plus something, 90 plus sine inverse, so this can be tan inverse, cos inverse, anything. 90 plus. If I want 90 plus something, that is our theta actually. In the problem we have sine inverse 1 over 5. Consider this as theta. Okay. So here the thing we want is 90 plus theta. Then think how I am going to get 90 plus theta for this sector or for this angle, because this is the angle covered by the particle. කොහොමද මෙන්න මේ angle එක 90 plus theta වෙන්නේ? මේක තමයි හිතන්න. If I mark my theta here, somewhere here, theta, then this becomes 180 minus theta. Why? This is 180. If this is theta, this small part becomes 180 minus theta. So that is not appropriate because we want 90 plus theta. 90 plus theta. Then if I draw a small construction like this and make this one as 90 and this small angle theta. Now can you see we have our target 90 plus theta. And මෙහෙම angle එක මෙන්න මේ answer එක දිහා බලලා ඉන්න ඕන 90 plus 180 minus එකක්ද කියලා ඒක හිතලා තමයි diagram එකේ theta එක mark කරගන්නේ. 90 plus theta. So this is theta. Both of these lines are horizontal, then this is also theta. With respect to theta, what is this? Opposite side. Opposite side is L over 4. Then what is this line? That is hypotenuse for this right angle triangle. This is a right angle triangle. This is opposite side. Time ඉවරයිනේ.
විනාඩි 9:55යි.
9 යා හරි. තව තියෙනවා. This is the opposite side. This is the hypotenuse. Both these lines are equal because D is the center. Center to C, center to this circumference point, they are equal. Amplitude was 5L over 4. We calculated that amplitude 5L over 4. So here I can substitute 5L over 4. That is equal to this hypotenuse. Then according to this right angle triangle, what is sin theta? Sin theta is opposite side over hypotenuse. Opposite side is L over 4. Hypotenuse is 5L over 4. Then L over 4 get cancelled. Sin theta becomes 1 over 5. Sin theta 1 over 5. Then තේරෙනවනේ උත්තරේ එනවා කියලා. Sin inverse 1 over 5. According to the expression we are marking 90 and theta everything. You should observe the given, show that expression. So theta is sin inverse 1 over 5. Okay, now we can apply our equation time equals angle theta. I will write it as angle over omega. So what is the angle covered? 90 plus theta. Pi by 2 plus theta over omega. Theta is sin inverse 1 over 5 over omega. What is our omega? Omega from previous section. Omega square is 4g over L. 4g over L. That is omega square. And omega is the square root. Therefore, time taken by the particle to move from B to C is angle covered 90 plus sin inverse 1 over 5 divided by omega 4g over L square root. Now I have to take this denominator to the numerator. So when I take this fraction to numerator, we have to consider its reciprocal. Denominator එකේ තියෙන එක numerator එකට යනවානේ. එතකොට ඒක 1 over වෙනවා. That means the reciprocal of this denominator. What is the reciprocal? L goes up, 4g down. Then 4 square root of 4 is 2, so I will write 2 as half, and L over g inside square root. Here we have 90 plus sin inverse 1/5. This is the expression they have given us to show. Half square root L over g pi by 2 plus sin inverse 1 over 5. So this is the pattern. You have to do this simplification. ඇප්ලයිඩ් වල තියෙන මෙන්න මේ වගේ සිම්පලිෆිකේෂන් ට්‍රික්ස් තමයි. එතකොට මේ සිම්පලිෆිකේෂන් ට්‍රික්ස් ටික තමයි ඔයගොල්ලෝ අල්ලගන්න ඕන.